Yes, how you doing? My name is Hamish, but a lot of people call me 25 Bacteria sometimes, but Hamish. No waste time. Let's go to the question. You face on my channel, subscribe right here. Okay, you see right here? Make sure you subscribe so every time when I put up new video, upload new video, you're gonna get notification automatically. So let's get started, man. So now they say consider the statistics, right? They say consider the below to be the monthly income, the money that you get for 10 drivers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh my goodness, somebody get a lot of money here, man. This driver got a lot of money. Okay, cool. So now they say find the following. Average. Average is easy. So the average means mean. Average means mean, and will represent by this letter here. So we say the average. This means sum. Sum, mean, average, the same. I'm gonna sum, but a sum from 1 means 1, 2, 3 to 10. So say stuff. Let's call I. Let's call this I's. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So start from 1 to 10 of these data. So this will call I, and this let's call X, I. So of all these X, I's. You know what I'm saying? Means I'm going to start to add them from 1 means 1, 2, 3, 4, 5. Or if you don't want to waste time with this, you can just say, oh, my mean equal, I'm going to have to add all of these. Okay, let's go for the first data. Say 10, 80, from 0. You can just say 1080 plus the second, because average means average. Add all these, divide by 10. So plus, you go for the second one, 2000, 1, 2, 3. We plus the third one, which is going to be 1580. We go for the fourth one, which is going to be 1540. And the next one's going to be 1540, and then 2500, and then we add the next one, which is going to be 100, and then we plus 1580, and then we plus 3000, and then we plus 3280, and then we go for the last one, we plus by 2930, and then all of these we can divide by how many of them they are? 10. So this is going to give us average, or you can call it aka mean. So average is going to be, so when you add all these 10, you see this one? When you add all of them, it's going to give you 21, I believe so, but you can plug it in, 21290 over how many number? The 10. And then this is going to give us, put the calculator, let me check my calculator quick, plug it in, but you have to do, sometimes I make like silly mistake and intentional. So put this in the calculator, this is going to give a 2129. So this is our average. So the average, we have it already, 2129. However, I'm going to show you how to use a calculator, and then you don't have to waste all this time, okay? So the one the face on is done, now we go for the median. Median is easy. What you do, you have to rearrange all this data. Start from the smallest one to bigger one. So now let's, okay, so our mean, which is average 2129. Oh, so our mean 2129. So our mean equal to 21 and then 29. So now we go for a median income. So median income, we say we have to rearrange all these data, start from smallest to the biggest. Okay, now let's rearrange all the data. Okay, so now let's go for the median. Rearrange all the data from smallest to the bigger one. Okay, smallest to the bigger one. Rearrange all the data, start from the smallest to the bigger one, and then I'll show you how to do it. Okay, cool. So for me, that I think is easy, but let me just do it for the sake of, Okay. So let's arrange all those data from smallest to the bigger one. Okay, so what is the smallest one? So the smallest one is going to be 1080. This is the smallest one. So it's like, say, 1080, the smallest one. Or maybe I can rearrange next to it so I can save space. Okay, so since we want to get median, let's rearrange here just so we can save a space. Now let's look. Which one is the smallest one here? Oh, it's 1080. So 1080 is the most smallest one. So 1080, exactly 1080. Most smallest one. The next one is 1540. 1540. This one, 1540. Okay, now let's go for the next one. The next one's going to be 1580. Okay, the next one's going to be, so this one is done. Then they go 1580. Let's go 1580 here. So make sure you range from smallest to the big one. So 1580, and now go for 1800. So we go for 1500. This 1500, 1800, and that's a 1800. You go for 2000. 2000 means rearrange all these data start from smallest to the biggest. Okay, now the 2000, and then go 2500. Okay, now 3 to go. 2930. Okay, now 2 to go. 3000, I think. 3000. And then 3280. Oh. No, let me say, excuse me. Okay. 2930, 3000. Now this is going to be 3000. And then we got 3000. I feel like less data now. How come, man? Okay. 10. Okay, we got 1080. Okay, 1540, 1540. And then 1580. But we have a 1580. Means this and this. So this one here should be 1580. Okay, so this should be 1580. 1580. Okay, let's do this. So this is going to be 180. Okay, let's see. So I have 1580, two of them. So 1580. And then it's going to become 1580. After 1580, 1800. 1800. And then after 1800, 2000. Now we go for 2000. 2000. And then 2500. And after 2500, now we go for 3000. 2500. And after 2500, 2000 to 930. Okay, now we go for 3000. And then go for 3208. So from there, after that, what you do, you cancel. You cancel one here, you cancel one here. You cancel one here, you cancel one here. You cancel one here, you cancel one here, you cancel one here, you cancel one here. So we left with 2. So you add them and then divide by 2. If you left with 1, that's your median. But for this case, since you left with 2, take those 2 and then add them together and divide by 2. So our median, for this case, is going to be our median income, median income equal to 1800, and then we add by 2000, 1500, add by 2000, and then divide by 2. So after divide by 2, this is what we're gonna get. Okay? So you take this one and put in calculator, add them. So so this is gonna give you 3800, and then divide by 2, and this is gonna be 1900. So this is going to be your median, okay? 1900. So that's your median. Now, mode. So mode is something which appear the most, okay? But which number appear the most among all of these? Something with the highest frequency. So our mode is going to be a number which appear the most, which is going to be this. These appear many times. So this go like which number appear the most? This. So that's going to be our mode. So our median we had already 1900. So this is 1900. But our mode, which number appear the most? Or the highest frequency number appear every time here, which is 1508. So that's going to be our mode. So we're done with the mode. So we go for the standard deviation, and then we go for the quartile deviation. Okay? Cool. So now let's go for the standard deviation and then for the quartile deviation. Okay, cool. Now we go. So what you do here, okay, let me get out the pen because my pen is finished, okay? Just get something here, okay, cool. Okay, so now, my pen is kind of finished, man. So now, let's go. So now this one here, they say, okay? Excuse me. So now, we want to get standard deviation. To get standard deviation, you know what you do? Get your variance, so find variance phase, and then after get your variance, what you do, you square root. So for now, we're not going to focus more on the standard deviation. Let's get the variance. And then when we get your variance, and then the business is gone. The business is done. So I'm going to say my standard deviation. Let me get my variance, excuse me. So my variance. But like I said, I'm going to show you how to do all this stuff, you know what I'm saying, without calculator, so you don't have to waste a lot of time. How am I going to get variance? We get variance by using the following formula. Okay? We get the variance by saying 1 over n minus 1, and then we sum. You know what I'm saying? We sum all these data. The data start from I equal to 1 for this case. I start from 1. I equal to 1. And then how many of them? 1, 2, 3, 4, 5 to 10. And then here you write your formula of standard deviation. Means you take your data minus the mean. And then what you do, you square. This represent this one, this data here, xi, all of them. And then each one you must minus by mean. Means take this xi, for example, take this minus the mean, which you have a mean average, and then you square. Now we go for the second one. You're going to take xi. What is the xi for the second one? This. Because this xi means x of the first one, x of the second one. So each one you must minus by the mean, which is constant. And then you square and then you add. Why we add? Because this meaning sum. Now we go. So it's our variance now. Our variance equal to 1 over, what is that n? N equal to 10. 10 minus 1 equal to 9. Because this is 10. 10 minus 1 equal to 9. And then we say sum. What is sum? Sum meaning I'm going to be adding for each one. Now let's go for the second one. For the first one, excuse me. So for the first one, I'm going to go now. xi. What is the first xi? So first xi is always 1080. So say 1080. And then minus by mean. Mean this x1. Mean. What does that mean? Mean is 21, 29. 21, 29. And then we say what? We square. Now we go until we finish all of them. Now we go for the second one. Well, the second one is going to be 2000. So this is going to be 2000. And then we minus by our mean. Mean, you see? Each one must means x1, means xi, means x1, x2. Okay. Minus our mean. What does that mean? Our mean is going to be same. 21, 29. 21, 29. And then we square. We plus. Okay. Now we go for the second. Why do we plus? Because of this. This means sum. Now we go for the third one. For the third one, it's going to be 1580. And then we minus 21, 29. And then we square. And then we plus. Now we go for the next one, which is going to be 1540. And then we minus by 21, 29. And then we add. We go 25, 000. 10,000 0 minus our mean. What does that mean? Our mean is 21, 29, 21, 29, and then we square, and then we plus. So you must be very careful with the number here, okay? Now we go for the next one, 1,800, and then 21, 29, and then we square, and then we go for 1580, and then 21, 29, plus, okay, 3,000. 3,000, 1, 2, 3, minus 21, 29. Okay, now we go for 32, 80. Minus 21, 29. Okay, now we go for the last one, 29, 30, minus 20, 21, 29, square. And they close your bracket because I open the bracket. Then all of these divide by, because means you have already done this. You know what I'm saying? And then all of these, no, we have already divided by 9. 1 times 9 multiplied by all of this stuff. Or if you don't want to write this 9 here, add everything and then get the answer divided by 9. Oh, excuse me, sorry. So now this is our variance equal to 1 over 9, or you can get the sum of these. Take a calculator, get a sum. Sometimes if you put all this in a calculator, it's not going to give you the answer. This is why I'm going to show you how to use a calculator without doing all this struggle. You put your number to get an answer. You know what I'm saying? But this is just to understand what is happening. So now this is going to say plug in a calculator, and this is going to give you 50. Sometimes if you plug all this, not going to give. So get some, get a sum, get another one, and then you get the answer. Because you plug one stuff in the calculator is going to fail. Sometimes sound that they can. Okay, so it's going to be 1 over 9, 1 over 9, and then bracket, and this is going to be 5, 0, 3, 7, 3, 7, 3, 7, 6, 9, 6, 9, 6, 9, 0. Okay, plug in the calculator is going to give 5, 5, 9, 5, 5, 9, 5, 5, 9. And then 7, 4, 3, 7, 4, 3, 23, 3. Okay, so these are variance. You know what I'm saying? I hope you can see that. That's a variance. Okay, so that's a variance. So after you get your variance there, you know what I'm saying? After you get your variance, so what you do? I'm not done yet. I want to get standard deviation. Means I have to square root this now variance to get standard deviation. So now I'm going to say, oh, come on, man. This is easy, baby. So I'm going to say, okay, my standard deviation equal, means SD, my standard deviation, equal to square root of my variance. So take your variance here, plug it there. So 743.33. So this is going to give my standard deviation. So now this, I'll plug it, is going to give my standard deviation. So if you plug in the calculator, this is going to give you equal. So my standard deviation is going to be equal to 748.16. But like I said, right, I might have made some silly mistake and intention. So make sure you put yourself accurate. And you feel free to leave a comment. So here, you know what I'm saying? So now this is going to be 5. It's going to give 748.16. So this is our standard deviation. So we have already standard deviation. Now we want to go for quartile deviation. You know what I'm saying? So let's see how we can get quartile deviation. It's easy, man. So to get quartile deviation, we kind of use the same strategy, okay? So now since I got my standard deviation, I'm going to write next to it, and then we can go to quartile deviation, okay? So now my standard deviation, for this case here, standard deviation. So I can just standard D deviation, so I can have a spacing. Standard deviation. Our standard deviation, we have. What is standard deviation? We say 748.16. 748.16. Now we go. So now let me get quartile deviation. So let me just make a space here and get quartile deviation. Okay, let's get a quartile deviation now. Okay, cool. Now let's get a quartile deviation. It's easy, man. Let's get quartile deviation now. Okay, so to get quartile deviation is easy. This is how you get quartile deviation. Quartile deviation, look, what you need quartile 3 minus quartile 1, and then you divide it by 2. And this is going to give you quartile deviation. But you know what I'm going to do? Quartile deviation. Let me show you. I'm going to explain to you how do they get all these quartiles in a box and whisker, because sometimes they're going to ask you to draw the box and whisker. You know what I'm saying? So now let's get all of them. Okay, let's put them all of them out of the way. So now we say, let's do something called box and whisker. It's not very important. This one I can show you quick. But let me explain to you so you can understand in and out of this question. Now let's get all the quartile. So quartile, let's start with the quartile 1. How do you get quartile 1? Okay, how do you get quartile 1? So to get quartile 1, okay, where's my pen? Okay, to get quartile 1, okay, we got 10 terms here. Quartile 1, okay, what you do say 1 over 4. You know what I'm saying? They say n plus 1. 1 over 4 n plus 1. That's how we get the quartile 1. Okay, now let's see 1. Or sometimes if you don't want to do that, you can say 1 over 4 is like 25 percentile times n plus 1. So this let me say 25% is like 1 over 4, which is this one. I'll just explain to you. Sometimes they might say 25 percentile. So 1 over 4 n. What is the n? 10. The 10. 10 plus 1. This is 11. 11 divided by 4. Let me take my calculator. 11 divided by 4. What you get? 11 divided by 4. 11 divided by 4. Okay, 2.5, 2.75, 2.75. So what is 2.75? Look here. Oh, so 2.75 is, you look at this number. 2.75 somewhere here is right after 2.5. Means it's more closer to 3. 2.75 is more closer to 3. Means quartile 1 is this number here. I'll say it again. So 25 percentile, or sometimes they call quartile 1, Q1, quartile 1. How you get it? You say, okay, 1 over 4. Well, sometimes you can say 25 percentile, n plus 1, so it's 1 over 4, n What is the n? For this case, n equal to 10 because our 10 equal to 10 plus 1, 11, and then put the calculator 2.75. 2.75. Where does it lie? It lies between here, but it's more closer to 3. So so I'm gonna take this is my quotile 1. Oh, okay. So my quotile 1, I can just say here quotile 1 equal to this number 1580. Now let's get quotile 2 and 3. Okay, quotile 2 now. We're going to do the same approach, almost similar approach. So it means it's going to be 1 over 2 here. Or you can say 50 percentile. Okay, n, what is the n? N equal to 10 plus 1. Now this let me say 1 over 2. What is the n? N equal to 10. 10 plus 1 equal to 11. So now this is going to be 5.5. So 5.5, if I come here, okay, 5.5 for quotile 2 is going to be, okay, let's go. Okay, so now we go. They are 10. So 5.5 is more closer to this. You know what I'm saying? Because if 5.5, you always approximate equal to 6. So my quotile 2 by any means, I'd rather take this. You know what I'm saying? Because I have 5.5 means it's like a 6. So I'll say, oh, my quotile 2, it give me which number? It's going to give me quotile 2 equal to 180. Oh, wait. I'm kind of wrong here. Quotile 2, excuse me, just a minute, right? Quotile 2 means median, which I had it already. And since I get 5.5, and it kind of falling in between. Okay, just a minute. 2500 plus 18000. Okay, the answer divided by 2. Okay, so quotile 2, I don't even have to bother because I already have my median. So quotile 2 is the median. Excuse my apology. Quotile 2 is this median, which I had it already. So there was no need for me to waste the time because when you say 5.5, oh my God, I understand why I was wrong. Excuse me. Oh my God, I was very, very wrong. Even for the first one, I was wrong because I'm supposed to use these data here, the data which has been rearranged. I'm not supposed to use this data which is not in order. This is the data I'm supposed to use when you use quartile and median and all these quartile. Mean the data which has been rearranged in ascending order. You know what I'm saying? I apologize. So this is the data we should use. So let me go back and check my quartile 1. Quartile 1, we say it's 2.5. 2.5 means is, look, 1, 2, 2.5 is almost close to 3. Yeah, still the same number. I'm lucky. Now we go to quartile median. So median we say, my apologies. Median 1 over 2, so 11, 5.5. 5.5 means somewhere here. Excuse me, my apologies. So 5.5, if this is 1,800 and this 2,000, so what you do, 5.5 is like a half of 5 and 6. So since it's a half, what I'm going to do, add this 2 and divide by 2. Because it's not falling on 6, it's not falling on 5. So what I'm going to do, just have to add this 2 and divide by 2. Because it's just 5.5. Or you can even see here, 1,008, 2,000 means the number between different them is 200. Split by 2, 200. This is going to take 100. This is, or add them by 2, divide by 2. So 5.5 means how I'm going to get it. So, okay, so 1 over 2. Take those two numbers. You know what I'm saying? Means take those two numbers because since it's falling here, the number because 5.5 is in the middle. So I'm going to say here, excuse me, 5, 6, 5.5. Take these 2 because 5.5 is between 5 and 6. So add this number together divided by 2, which is when you add is going to give you 3,800 divided by 2, 1,900. Oh, so my median is 1,009. My median or sometimes quartile 2. So quartile 2 meaning median. So sometimes you can call median 1,900. Now we go for quartile 3. Oh, so quartile 2 equal to 1,900. But if you have your median, don't bother because quartile 2 meaning median. Now we go for quartile 3. Quartile 3, the game is the same, guys. You know what I'm saying? Now we go to quartile 3 or sometimes we call 75 percentile. Quartile 3 or you can call 75 percentile. 75 percentile. And then n plus 1, or you can say this 3 over 4 because 75% means 3 over 4, and they say n, what is it? N, 10 plus 1 equal to 11. So 3 over 4 times 11. So take a calculator. 3 over 4 plus 11. So 3 fraction 3 over 4. Okay, 3 over 4, and then come here multiply by 11. And this is going to give me 8.25. So 8.25, now we do the same thing. 8.25, look, you take this, the one which is arranged in order, okay? Now we go 1, 2, 3, 4, 5, 6, 7, 8. So is closer to this. You know what I'm saying? Because it's not yet in 9. 8.25. Come on, man. 8.25 means it's here. You know what I'm saying? So it's somewhere here. Okay? So 8.25 is going to be here. Falling here. Okay? So my quotile 3. Okay, so my quotile 3 is going to be falling in here because 8.25 is not close to 9. So I'll take this. 2930. So my quotile 3, 2930. Okay, I got my quotile 3. So I have a quotile 1, 2, and 3. So there's something called boxing whisker. They ask you to draw boxing whisker for more time. So my quotile 3, I got quotile 3, 2, 9, 30. Now let's draw boxing whisker. They ask you this every day, every time. You know what I'm saying? So I'm gonna raise this and I'll draw boxing whisker, and then I'm gonna show you standard deviation also, the quotile deviation. Okay. So now let's draw boxing whisker. The boxing whisker, what you do, like I said, use those data there which are in order. Okay, boxing whisker. So boxing whisker, what you do, first and foremost, write your boxing whisker, which is here. Okay, what is your lower quotile? My lower quotile is quotile 1. So right here, this is quotile 1, which is 1580. And then go to quotile 3. Don't write quotile 2. I'll tell you why. What is my quotile 3? Let me do this. My quotile 3 is 2930. So now look, quotile 2, make sure when you write the last. Why? Because it's 1900. So now you come, is 1900 close to this or close to this? Oh, it's more close to it's more close to this. 1900 is more close. So even when you draw your box and whisker, you must use a lot of common sense. Means 1000 quotile 2 and 900 is more closer to this than this, because this is like another 1000. So here, and this is like 400 or 300. So this is quotile 2, 1900. You know what I'm saying? And then after that, you're gonna draw line and line. But also you have to use the common sense. This line is gonna go, means you have to look all this data and look what is the biggest number, 3200. From here, 2900 to 3200, how many is like 300? But from 1800, 1080 to the smallest number is like 500. So I have to use the common sense. From here means 1500 to 1008 is like 400, but from here to 2300 is like, so this is shorter compared to this. This is more longer compared to this, because this is like 300 to the highest data, which is 3280, but this is 1008. So this we call it box and whisker. They ask this every day. So this is box and whisker. So this is my box and whisker. It's not part of the question, but they ask you this every day. Whisker. Hope whisker. Yeah, box and whisker. I think so. Yeah. So this is a box and whisker. So this is your box and whisker. So this is minimum data, and this is quotile 1, quotile 2, which you sometimes call median, and this quotile 3, and this is highest data. So now they ask for quotile deviation. Quotile deviation means how does this quotile range? So how we get quotile deviation? Quotile deviation, QD, or you can write whatever quotile deviation, equal to quotile 3 always minus quotile 1 and then divided by 2. So quotile 3 minus quotile 1 and then divided by 2. Okay, what is the quotile 3? 2930 minus quotile 1. Okay, quotile 1, 1580, and then divided by 2. So put in the calculator, divide, and this is going to give you 63. You know how to pull this, okay? It's going to give you 675. 675. So this is the quartile deviation. So quartile deviation equal to 675. Minus this divided by 2. Take this minus divided by 2. So this is a quartile deviation. In other words, how does this deviate? Quartile deviation divided by 2. You know what I'm saying? So we got a quartile deviation, I believe so. Yeah, quartile deviation. So something quick here. Sometimes they may ask you something quick. In this question, let's say find what is upper quartile. This is our upper quartile. What is lower quartile? This is lower quartile. Okay, alright. So now, let me just, so this is a quartile deviation, got it, 675. Now, sometimes they're going to ask stuff like this. What is interquartile range? Interquartile range. Interquartile range. Interquartile range. Interquartile range. Interquartile range means these are quartile. Interquartile range means take quartile 3 minus quartile 1. And this is going to give us, it's going to say 2930 minus 1580. And this is going to give us, if I'm not mistaken, plug in the calculator, 2930, 2930 minus 1580. Okay, this is going to give 1350. So, interquartile range is 1350. 1350. Okay, sometimes they ask you find range, just a range. Range. So how you get range? Take maximum data. You see here? Look at the with the biggest number. We know biggest number this minus lowest number is that. So that's our range. So it's very important to arrange your data from the lowest to the maximum. So range is 3280 minus minimum data 1080. And this is going to give us our range. Okay, 3280 and then 1080. Okay, 2200. So range equal to 2200. So range equal to 2200. So this is a range. Another question, excuse me, another question, let me think. Okay, what is the minimum data? Minimum data equal to minimum data. Minimum income, if you say minimum income, but it depends. For this case, income, it could be minimum score, minimum weight, minimum marks, or whatever they could say, or minimum population, whatever. So minimum, for this case, minimum income, or let's say minimum data, because it's all going to change. Or for this case, income. What is the minimum income? It's going to be 1080. Maximum income, the biggest one. Maximum income, or maximum data, in other way, because like I say, it's going to change, equal to 3280. Yeah, look, man, I think I covered for this, okay? Now let's go for the next question. You know what I'm saying? So FaceTime, make sure you subscribe, bro. I'm Hamish, like I say, but a lot of people sometimes they call me 25 with T, okay? Subscribe here so you get notification automatically. You got, please, I'll be very, very happy to respond to your comments, okay? Leave the comments, subscribe, FaceTime, click the like button. You know what I'm saying? Thanks a lot of peace. I'm out.